This is the problem number 1 in section 1.4. An automobile manufacturer makes a profit of $1,500 on the sales of a certain model. It is estimated that for every $100 of rebate, sales increase by 15%. Part A. What amount of rebate will maximize profit? The 5-step method can be applied for this problem. So, step 1, ask the question. Here, we should define our variables, then assumptions, then objective. Variables, we have rebate here, so we should use R equal rebate. So let me use S, number of cars sold, then P is the profit. So these are the variable. So then we need assumptions. Before that, I will define, I will use S naught for the number of sales without any rebate. So number of sales without any rebate. Then consider this. If we sell S naught number of cars after rebate, 100 of rebate, sales increase by 15%. Then how many cars they sell because of rebate, $100 rebate? So how do we find it? 15% mean 0.15 multiplied by S naught. So this is the number of cars they sell because of rebate. Now go to the assumption. S is the total number of cars sold. How do we find this? You know, we have S naught. It is the number of cars without rebate. Then it increased 0.15 for the 100 of rebate. 0.15 multiplied by S naught. 0.15 S naught. This is the uh, number of cars they sell because of rebate, $100 rebate. But our rebate is the R, therefore, if this is for the $100, so we should multiply by R over 100. So then you can simplify this as naught 1 plus 0.15 R over 100. Now write an equation for the profit. So profit P equal how many cars they sold, S number of cars, and what is the profit, 1500 from each cars. Therefore their profit should be 1500 for one car multiplied by number of cars S. But they offer a rebate, therefore it should be minus our rebate is the rebate is R and number of cars is S. R is for one car and then total rebate R time S. So then you can simplify this 1500 minus R time S. So you know very clearly S greater than equal 0. It can be 0 or greater than 0. And R, the rebate, can be 0 or greater than 0, maybe 1500 or less than 1500. So this is the range of R. What is the objective? Maximize maximize the profit. That is our objective. Next, step 2. Step 2. What is step 2? Select the modeling approach. The book says use the 5-step method and model as a one variable optimization problem. So it is a one variable optimization problem. So y equal fx. Then you can get a derivative and set it equal 0. Then solve for x. So that is the step 2. Then step 3. The step 3 is the formulate the model. Okay, first let me write down the our profit equation. P equal 1500 minus R time S. So this is the equation, but we know the S. Therefore, we can write down 1500 minus R S equal S naught time 1 plus 1 plus 0.15 R over 100. So this is the P. Now let x equal R and y equal P. Then we can write down the function y equal fx. Y equal fx. This equal 1500 minus x 1 plus 0.15 x over 100. I know s naught, so I write down over here. So our goal is to maximize fx over the interval 0 to 1500. Then step 4. Under step 4 we solve the model. Okay, first how do we do this? Get the derivative f prime x. F prime x, you can get 1500 minus x, then derivative of this 5 over 100 plus 1 plus 0.15 x divided by 100 time minus 1 time s naught. So set f prime x equal to 0, solve for x, then you will get x equal 416.6667. So this means you will get the maximum value of x maximum value of fx at x equal 416.6667. So how do we find the maximum? Just plug the 416.6667 to the equation of fx. So this one. So you will get 1760.42. So this is the maximum value of the function. First step 5. According to this model, the optimal policy is to offer a rebate of around 420. Rebate of around 400. I just 400 is the exact price, but $420, which should should result in about a 17% increase in profit. Part B. Compute the sensitivity of your answer to the 15% assumption. Consider both the amount of rebate and the resulting profit. Okay, they are talking about 15% assumption. So let me write down the model we use. The part A, y equal fx equal 1500 minus x 1 plus 0.15 x over 100 times s naught. So you see here in this term 0.15 divided by 100. So I will simplify that part. Then it can be written s naught time 1500 minus x 1 plus 0.0015 x. So we can use this one as a variable now. Therefore, new model can be written in this form: fx equal 1500 minus x 1 plus I use ex s naught. So then get the derivative with respect to x. So you will get, I will write down s naught at the beginning now, 1500 minus x time plus 1 plus ex time minus 1. So then set this equal to 0, solve for x. So you will get 750 minus 1 over 2e. Okay, this is the x. Then what is the next step? Get the derivative with respect to e. Let me remind you, sensitivity is x here e equal dx over de time e over x. So now find the dx over de. Dx over de equal, according to this, 1 over 2e to power 2. Therefore, we can write down the SXE sensitivity equal dx over de 1 over 2e squared times e over x. So now we know e value and x value. So we can plug those values into this equation. So SXE equal 1 over 2 equals 0.0015 to power 2 time e 0.0015 divided by x 416.6667. So answer is zero point 0.8. So we can write if the rebate is 10% more effective, then we thought then the optimal rebate will be optimal rebate will be 8% bigger. So a similar computation yields s y comma e equal 0.38. So that if the rebate is 10% more effective than we thought, then our optimal profit will be 4% greater. So that is the answer for part B.